So we are getting the sum of border elements, and let us display the sum of border elements. And we have not declared these variables. We have not declared the variables integer variables I, that means looping variables I j. So let us declare it. So I j, then some row, sorry, some border, sum of border elements, that is represented by a variable sum border. And since it is going to be used for summation purpose, let it be initialized by 0. And let us assume one more variable, sum non-border. This variable can be used to represent the sum of non-border elements, and since that is also going to represent the sum or addition process, it can be initialized using 0, right? And one more thing is, we are using scanner in our program, and we have to import the util package in our program to make scanner class known to the program or Java runtime environment. So java.util.package, java.util.start. So the util package is imported into our program. Now this program will actually give the sum of border elements. Let us compile the program, and some errors are there. So unclosed string literal, that means the double quotes, opening double quotes is missing actually. Now let us check again. There is no error, syntax error in the program. And let us check the program now. Let us execute the program now. So enter the elements of the matrix. Since it is assumed that it's a 3 cross 3 matrix, we are supposed to enter 9 elements as input. Right? Let us enter 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements are actually entered, and now the sum of border elements is 40. Actually, we are not knowing which are the border elements because this matrix is not displayed, or this array is not displayed in the matrix format. Let us discuss how to make or how to display this array or double dimensional array in the matrix format, right? So once you get the matrix as input from the user, let us have another set of another for loop, nested for loop for I equal to 0, I less than 3, since there are 3 rows, then I plus plus, then and the outer for loops denotes the number of rows or the rows in the matrix. Then let us write one inner for loop for j equal to 0, that is the first column, then j less than 3, that is the last column, then j plus plus. So now when you are using a particular value of I and corresponding value of j, it will represent a particular element, but we want to display it in the matrix format. So in the matrix, in the first row, for example, when I is 0, it represents the first row, and that particular row will have 3 columns, right? That means column 0, column 1, and column 2. So all the columns in that first row should be displayed in the same line with a small space to represent that particular row or columns in that particular row. So what you can do is you can use system.out.print to display that particular element in every column of that row. So num of I j, it is representing that element in that column, right? After displaying that element, you can leave a small space, right? For example, 2 or 3 spaces to differentiate the current element of the column in the next element from the next element. So now what will happen when I is 0? It will display. It will have value 0, and this representing the first row, and j starts from 0 and I is 0 0. That means it will display the first element in the matrix. Then I is still 0, but j is it is incrementing to 1. So 0 1, and it will represent the second element in the same row, second column in the same row. So it will print this value in the second column in the same row. Then I is still 0 and j is actually 2 and 0 2. It will print the third element or third column element in the same row, 1. That means row 1. So like this, I will become 1 now. So when the inner for loop finishes all its iterations, again the next iteration of the outer for loop will start by having the value of I as 1, and again it will repeat. So every time the inner for loop will print a particular set of columns in a given row. But once your column elements are printed, the next row should be printed in the next line. So what you can do is, after printing every element in that particular column, you can display an empty, or it can move the cursor to the next line by using an empty println statement. So it will just move the cursor to the next line, right? So now you can compile it and you can run it. So now there is no syntax error, and let us execute the program. And again, 1 2 3 4 5 6 7 8 9. See, now the matrix is displayed in the proper format, in the matrix format. See, now you can check whether the sum of border elements is 40. So the border elements are 1 2 3. So 1 plus 2 plus 3, it is 6. Then first row, then last row, 7 plus 8 plus 9. So 9 plus 8, 17 plus 7, 24. So here 6, 24 plus 6, 30. Then again the first column, and first column already the first element, sorry, the first column, the first element is already included in the first row, and the last element is also included in the last row. So only remaining is 4. Then here again 6. So 1 plus 2 plus 3 plus 6 plus 9 plus 8 plus 7 plus 4 is actually 40. So the sum of border elements is 40. Now this program works for the sum of border elements. Let us display the sum of non-border elements. So what is a non-border element? An element that is not lying in the border is called not border element. So if an element's row index or column index is not satisfying this, right? That means its row index is not 0, or its row index is not 2. That means the last index of the last row, or the row index is not column index is not 0, and its column index is not actually 2. That means the last index of the last column. In that case, that element is not lying in the border. So what can you do is, you can use the same condition. You can use the same condition, and you can instead of using I equal to 0, you can use I not equal to 0. I not equal to 0. That means its row index is not 0, or its row index is not 2, or its column index is not 0, or its column index is not 2. In that case, it's a non-border element. That means the element is not in the border, right? Now what you can do is, you can represent the sum non-border sum non-border is equal to sum non-border plus the element is added. If the element is not lying in the border, then it will satisfy this condition. If it is satisfying this condition, then you can add that element num of ij with the sum of non-border elements variable. Now sum of non-border elements is also available. Now let us display the sum of non-border elements too. See, sum of non-border elements is sum of non-border. So the variable is representing some non-borders actually representing the sum of non-border elements, right? So now let us compile the program, and again the program is syntax free, and let us run the program. Again, let us enter the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. See, actually there is a problem in the program. Let us check it. Okay, so some logical error is there. It is not mandatory that the program is logical error free. There will be a lot of logical errors possible, and what is a logical error is an error that will make your program running, but at the same time you will not get the proper output. Okay, so when I is not equal to 0, and when actually what is the problem here is, you see, I checked whether I is not equal to 0 or I is not equal to 2 or j is not equal to 0 or j is not equal to 2, and actually an element that is satisfying any of this. Okay, actually that element should not be in first row, or that element should not be in last row, or the element should not be in first column, or the element should not be in last column. That means it should satisfy all this. That means everything should be satisfied. Okay, everything should be satisfied. So instead of using or, you can use and in this place. So if you are using OR, if the first one is not satisfying, the second one will be satisfied. So automatically that element will be taken. But the thing is, here none of this should be satisfied. That means that particular element should not be in first row, and it should not be in last row, and it should not be in first column, and it should not be in last column. So that's why we are using the and no logical and between this conditions, right? Let us compile the program again and check it. Illegal start of expression, yeah, one more and ampersand symbol is here, right? Let us compile the program again, right? Now it is syntax error free. Let us run the program. So 1, 2, 3, 4, 5, 6, 7, 8, 9. See, now the sum of border elements already we checked, it is 40, and the only non-border element in this matrix is actually this 5, right? Because that is not in the border row and border column. So now the program is giving the proper output, that means sum of non-border elements, right? So I hope that you understood the logic of this program, and okay, and now okay, you can go ahead with the little complex programs in the matrices, right? And in we have a lot of other videos waiting with this kind of matrix like programs, and wait for it, and please view the other videos and subscribe the channel for other videos, and thank you.